I was here for Remars, and we were having a lot of fun as usual at the DeepRacer pit. And Anthony came in and he's like, "Oh, have you tried putting reinforcement learning on an actual size car?" And I'm like, "No, would you like to?" "Yeah, sure." So what started as a conversation became something of a project, and later we're going to talk a little bit about the details. So we'll start out with team introductions, and then we're going to move on to a little bit about the overview of how we were able to use the tools that are provided in the backend of DeepRacer, such as Amazon SageMaker and AWS RoboMaker. And then we're going to talk a little bit about our upcoming paper, which is going to be presented in March in Detroit. So hope to see you in Detroit. Great town. We're going to do a little bit of a deep dive in the architecture and show you how it differs from what is happening in the toy car versus what is happening in the actual size car, and all the measures that has to be taken and one-to-one mapping that has to be considered. And finally, we're going to show you some amazing videos that our crew had taken along with our safety driver, also Anthony here. When we have the actual reinforcement learning, steering, not so well initially. Remind you of the high school days probably. Luckily we have a safety driver. So we're going to show how we were able to actually improve upon the design so that we can drive smoothly still using the reinforcement learning. With that, I'm going to pass to the team to introduce themselves. So starting with Anthony here.
Hi there, my name's Anthony Navarro. I was the winner of Remars, so right here in this room. I'm a solutions engineer at Polysync, which makes a drive-by-wire kit for autonomous vehicles, which you'll find out a little bit more about later. I'm also trying to be an astronaut, and that's how I spend my free time. So.
Hi, for those who doesn't know me, I lead the science team for AWS DeepRacer. I'm one of the original innovators of DeepRacer, along with a very hardworking, large crew of SageMaker reinforcement learning and RoboMaker team. And I'm glad to be here today.
Hello. Good afternoon, everyone. My name is Prem Ranga at the last. I'm a solutions architect with AWS based out of Houston, Texas, aligned to our machine learning practice. I'm one of the pit crew, so working really hard, making sure DeepRacer goes well at reInvent. I'm also a simple beer service dev engineer, so created this, I think it's there in one of the hotels. It's in the Builders Fair. So that's Alexa-controlled beer pour. So that's me.
All right, so as Sahika mentioned, when we were here at Remars, I kind of brought up the idea of, hey, this is really cool, I'm having fun with this. Have you ever thought about putting it on a real size car? So some of the stuff that I've done in the past is taking a full-size vehicle and sending it around a track. And again, the company that I work for, Polysync, makes a drive-by-wire kit that basically abstracts the vehicle away and gives you just a USB connection and software interface so that you can start controlling a vehicle. And so we decided to take models that were trained on AWS, basically the DeepRacer models. We would take the drive-by-wire kit. We worked with a university, Western Michigan University, to do the integration of our kit and of the DeepRacer code to work with our kit. Both of them run on ROS, and so that made it very easy to work with. And then we were using reinforcement learning to autonomously control a Kia Niro around a racetrack. Go ahead. Oh, one more. So as Sahika mentioned, we're going to be writing a paper very soon for SAE World Congress, which is an automotive conference out in Michigan. So this is going to build upon another paper that I've written that had to do with deep learning, basically, using convolutional neural networks. So we did this testing, wrote a paper on it. It's on my LinkedIn if you're interested in finding it and seeing that publication. And this is kind of the follow-up, because that was very interesting, but you need a lot of data. So the reinforcement learning is kind of an interesting way to go about it, and Sahika will get into kind of how we're doing that.
Thank you, Anthony. So we started with Anthony's paper, which was using supervised learning, and most of the approaches that you had currently been seen in the literature focused on image collection and then using a supervised learning to map what you see in the image to how the steering and the speed is going to work. So as you are familiar with the DeepRacer, what we try to do is try to learn the steering and the speed as we move along the track with giving some rewards. So what we ended up doing is, can we work with the concepts of deep learning? So on one side we have an agent is in the DeepRacer, and this agent is a neural network, and this agent is going to be mapping directly, as in DeepRacer, the images to the controls, which will be driving for steering, and it's also going to be speed. So if you think from the DeepRacer perspective, it is relatively the same tool sets. However, we had to make some tweaks, and we're going to do a deep dive on that. So one of the things is that the car, the actual size car, now I'm going to say, oh, it's really different than a toy car, and you will say it's obvious. So one of the things that we had to really work on was currently our reinforcement learning that enables DeepRacer to drive is going to be giving discrete commands such as steer 30 degrees, steer 15 degrees, and it will also control speed fast, speed slow. You can technically add stop as a condition as well. However, this doesn't directly map into the braking and gas pedal. So in the actual car, you have a gas and you have a brake, as you all know. So theoretically, that you control over two knobs, while DeepRacer, or the way the agent is currently set up in DeepRacer, is you have one knob for the speed. So Prem is going to do a deep dive on how we work with the Western Michigan University to better understand how we can enable, with the metadata that is coming from the DeepRacer and the low-level data that is on the actual car, where we have one knob mapping into several different knobs.
Thank you, Sahika. So with that, we'll deep dive into the architecture that we implemented. Think of this as a 200 level architecture. So on this side of the architecture, so these are components from the DeepRacer itself. So we've got the camera. So we do have an OpenVINO inference engine for model inference. So the navigation node takes predictions from the inference, converts that into steering and throttle messages, which is what you actually have in the DeepRacer today. That's sent to the PWM controller to control the servo of the DeepRacer. But what we did was, instead of allowing that to happen, we kind of put a bypass in there in the DeepRacer ROS nodes. So basically, DeepRacer is full of ROS nodes, robotic operating system nodes. So we subscribed to this autonomous drive topic, and then we created a simple transformation node, which then took the messages from the topic and sent it to three separate PID controllers, proportional integral derivative controllers. Sahika from the science team will talk about it in more detail later. But basically, so we kind of took the steering input to the steering PID node, throttle to the throttle PID node, brake to the brake PID node. And then we wrote a couple of nodes for transforming the output from the PID nodes. And then we had to send messages to this particular box here. So this says ROS CCO. So that's the ROS node for the open source car control interface, which Anthony's company Polysync has built. So what they've built is a drive kit there. So this is a ROS interface for the drive kit. And so what we do is we integrate with the ROS interface for the drive kit. And thereby we are able to see messages coming in from the DeepRacer, take the inference messages out of that and directly send that to the drive kit, which then controls the car. So Anthony, do you want to say a few words about the drive kit?
Yeah, so again, like I said, drive kit is made to abstract a vehicle. As most software developers, they don't want to get into the vehicle, have to understand the CAN codes, the messaging, the balancing of the CAN network, all of that. We take care of all of that and kind of abstract everything away. For the OEM, we're basically protecting their CAN signals, so it's still not exposed to the developer, but the developer has access to control those systems and to also get feedback from the vehicle, so that if you can see right here, if you need to add a feedback node, you're able to do that. Drive kit's a pretty straightforward system. that installs in a vehicle in under an hour and is completely removable from that vehicle after the fact if you don't need to use it anymore. And we use ROS in order to tie in with things like this, and just the developer community in general likes to use ROS a lot. So that's one of the reasons we developed ROSCO, which is an open source thing you can go find and kind of see how those messages and how that all of that works.
All right. With that, we're going to get to the fun stuff. Right, some videos. So this doesn't go in a clockwise or an anti-clockwise direction. It goes in a haphazard direction. But I'm going to play the first video. So this video was when we directly took the output from DeepRacer and we sent it to the car without making any changes or adjustments to the integration architecture. Not playing? Yeah, there you go. So that is how the steering behaved when we directly send the output, because as you know, the DeepRacer is a small size car and it kind of does this when it's learning, and we directly took that and sent it to the Kia Niro. So what you have here is students from the Western Michigan University. So we were in their autonomous research lab, and Anthony had wired up a Kia. So we connected DeepRacer to that Kia and we directly sent this. So as you can see here, we are showing a simulation video to the camera of the DeepRacer, and then we directly sent it, and this is what we saw. So what we then did was, so that was interesting. So what we wanted to do was we wanted to understand if, let's say, if there is a car that's going to steer itself like that and we sit inside the car, what's going to happen? And that's the second video that I'm going to show you. And this is what happened. So this here is Anthony, our safety driver, also aspiring Mars astronaut, and that's what the car did. So yes, thankfully, so he was experienced. That's why we didn't get into a crash or anything like that. But what it literally did at the outset was it was just doing donuts. So it was kind of doing this all the time, right? So that's where we were, and then so we didn't have the PID node, so we didn't have the PID controllers in the car before. So once we added the PID and we started streamlining the inputs and also took some feedback from the vehicle, so we were able to smoothen out the initial interruptions that we had. So let me show you that video. So that is this one. So this again went back to the storyboard or went back to the lab and added the PID controller, and then the steering became much more experienceable or much more comfortable. So that's what we did. And finally, after that, we got confidence and we kind of went to the parking lot again of the Western Michigan University, which had cars parked in it, which had lampposts, and which had some trailers and everything there. But we once again went with Anthony and tried it once again. So what's not visible here, but the car has actually started to move now. This small thing there, but it was much more, let's say, manageable, and the experience sitting inside the car was not so bad as it was before. And then what happens is the car actually started turning left based on what the DeepRacer simulation was pointing it. And then Anthony had to grab control of the car because there was a car parked in front of us on the left. We didn't want to go and crash into that car, so we took control of it. So that's basically it. So what are the next steps? For that, I'll hand it to Anthony.
Thanks, Prem. So the parking lot was fun, but we want to be on a racetrack. So next week we've actually got time booked in Portland on this racetrack right here, and we're going to send the cars around, see how DeepRacer trained algorithms actually perform on a real racetrack. And, hopefully everything goes well, and I want to convince them to do this, Evo stuff next year, put some multiple cars on there, see how that goes. But yeah, that's it. Thank you very much.
So you were training it on the so which track basically for the DeepRacer, and were you using the same model directly on the actual parking lot or the track?
Sahika, I want to take this.
Yes, it's actually the same. The only difference is that the actual car steering is 600 degrees. So, the steering wheel and the tires are differently scaled. So that was one thing that we fixed. And the second the same track. Just the reinvent track. So our initial experiment, the first phase is we want to make sure that whatever control command that we send, car responds as expected. So if on the simulation we say 15 degrees, we want the car to do those 15 degrees. Before that mapping, we couldn't really train a model on a new track. So one of the experiments that we're going to do when we're at the Oregon track is to collect data and then push that data into our simulation and generate a simulation environment. So next time we can go evaluate on that track. So the perception part is not there yet, but the perception part was what Anthony published the year before. So we really focused on the undone part, which was mapping of the DeepRacer's or RL agent controls into actual vehicle steering, braking, and throttle controls. Yeah. So the simulation on an actual track is the next step.
Here. I think I'm asking two questions. Let's say you are able to go to the track and perform it very nicely. Can I use the same model to some other track? Is that possible?
It depends. So it depends on how you trained your model. If you go to Archive, we just published a paper on our own experiments on different types of models and different hyperparameters and the way we train them. For track variability, what we had seen is instead of, if you used a SageMaker notebook for DeepRacer, you can have multiple rollouts and you can train on multiple tracks. And we had seen that those multiple tracks translate really well. Especially the Tokyo and London track has lots of right and left turns, and we had seen those perform really well on unseen tracks. Yeah.
Thank you.
Was that drive kit, is it a retail device? Is it something you could just buy?
Yeah, it's something. Yeah. The question was, is that drive kit something you can buy? It is. It's something we sell commercially, so if you're interested, you can come talk to me and I can let you know a little bit more information about it.
So for the PDX track next week, have you built a gazebo version of that or? Okay.
We have not, no.
And what's the objective of the next week's exercise? Is it just to finish one lap on the track or try to get as fast as possible?
Well, I think we'd like to finish a lap on the track, or as fast as possible.
I can take that. Thank you. So the objective for next week is primarily collect data. So basically, so with reinforcement learning, the advantage is you can actually train sophisticated models without lots of training data, right? So the objective is the little training data that we want to collect is we're going to mount a camera at the front of the car, and then we're going to have the car drive through the track that we have in Portland, and then get those videos, and then use that to create a simulation environment. And then train a model on that simulation environment and then directly deploy that and have the car drive itself. So that's the plan for next week.
What's that? Behavioral cloning? No, not really. That's kind of what we did with the previous paper that I wrote. We took the deep reinforcement stuff, said, here's how you drive a lot, and try to do that. So that's what we did in the previous paper. This is a different approach because the vehicle, it's unsupervised. It doesn't have an idea of what to do, but it does help to have the environment that you're going to train in, just like it helps to have the racetrack to kind of, in simulation.
Thank you very much. Any more questions?
We do have a few more questions that came in from the community. The first one was, how do you streamline the car controls?
Streamline the car.
How do you streamline the car controls?
Yeah. So the pit controller is so ROS has got a inbuilt pit controller. So what I can do is so when you have ROS 1, you can actually directly launch pit controller nodes directly using your ROS launch files. And what we did was so we did a lot of trial and error kind of a testing. To smoothen out when you saw the videos, the first video was the steering going crazy, and then the third video was steering was much more manageable. So that was the evolution of using the pit controls to streamline what the actual car was supposed to be seeing based on what the DeepRacer was telling it. So that's how we did that.
Very good. Another question was, how does the drive kit work?
I think there is a question from
excuse me. Okay. And how was the integration architecture built?
Okay, so drive kit, Anthony, do you want to take the drive kit question?
Yeah, I mean, it's a hardware device that we tie into the vehicle through certain connections. We basically do sensor imposition, so when you have sensors that are reading the steering torque, the acceleration, or the brake position, the pedal position, we can intercept those commands, and if they're not supposed to go to the vehicle, and we can kind of put our own on there instead, without having to flood the CAN network, because CAN networks are very balanced. And so with a lot of approaches where people just send a lot of commands over the CAN network, that's not really a great safe way to approach it, because the manufacturers designed the CAN network to work in a certain way and with a certain balance. So basically, we just sit in between certain vehicle sensors and the ECU to actually perform that. And so either we can let those messages pass through and you can use the vehicle just as normal, or we can interrupt those messages and we can send our own based on whatever computer you have hooked up to DriveKit.
Maybe I can ask, sorry, I had one question.
Yeah.
Is there any way that the community members could contribute to your project?
Sure, I'm on Slack channel. Just contact me.
Yeah, but in what way could we contribute is the question actually.
It depends on your background. So this is a really kind of let's see how it works.
Okay.
And there are any research challenges.
There's actually, and I kind of glazed over it, but there was a link in there, selfracingcars.com. That's an event that I've participated in for the past 3 years that allows you to kind of, if you have an autonomous vehicle kind of set up, and people have homebrewed ones, there's companies that come out there and they let you go on the track and actually send your car around. So that's been a lot of fun. I think, the group that I work with, we're kind of looking at maybe mentoring versus actually participating, but it's a great community. But like Sahika said, I think that's more to come. Like if we can figure out a way, really all of our time is just crazy busy, and so it's hard to kind of, nail something down. So for us, it's an experiment right now, but I think it'd be great to have this driven by the community, because, I think both companies, all of us really like to see these community-driven projects. So selfracingcars.com.
So I guess it's interesting that you guys had to figure out how to deal with brakes with DeepRacer. Is there have you guys experimented at all with like braking action for the current iteration of DeepRacer, or like one of the actions, instead of throttling to, half the max setting or whatever, have like a brake so that you could kind of come up fast on a curve and then slow the car down a little bit?
Yeah, we actually spent a lot of hours holed up in that lab in WMU to solve that problem. So DeepRacer doesn't send any brake signals at all. It only sends throttle. So we actually did a couple of things. One is, so we kind of set up this feedback node where we could look at steering angles as well as car acceleration and car velocity and car throttle speeds from the actual car itself. So the first try that we did was we tried to kind of capture that and send that as an input, as a feedback loop for the pit controller to kind of determine at what point in time, based on what DeepRacer tells us, we should send a throttle command or we should send a brake command. And we kind of kept the throttle and the brake commands mutually exclusive. Meaning if I send a throttle, I don't send anything to the brake. If I send a brake, I don't send anything to the throttle. So that kind of led to some challenges or also some improvements. But in the end, what we did for this version, but we're going to change that next week, is we kind of looked at values. So we kind of maintained the state of what DeepRacer was telling us within our nodes. And then based on a set of values, a sample of values, we kind of determined if the DeepRacer was trying to go slow or go fast. And if it was trying to go slow, so we kind of calculated a value that we will send to the brake command so that it will brake and not throttle. And if it was trying to go fast compared to where it was, we will then send that to the throttle command and send nothing to the brake command. So that's how we solved that problem. But there are definitely scope for improvement there, and that's what we want to figure out based on the data that we collect next week.
Thank you very much. Do we have any more questions at all? Wonderful. All right, let's give it for Sahika, Prem, and Anthony. Thank you. Thank you very much.